Okay, we're going to start graphing these. We go back to chapter 6 for this in the book. First thing I want you to see, maybe, all trig functions are what we call periodic functions. And what that means for you is that your function is just going to keep repeating itself over and over and over and over and over forever and ever and ever and ever and ever. What that means for us is we are only going to graph one period, because if we can graph a period of the function, then we know what is going to happen forever and ever and ever. What I have for you here is just two sketches of functions so you can get an idea of what periodic really means. One of these is periodic and one is not. Which one genuinely repeats over and over and over? The one on the left or the one on the right? Left. The left. Why is the one on the right not periodic? Yeah, because while it's making the same like shape over and over, it's going up. It's not staying around x multiple times or whatever it is. Okay? So the one on the left is periodic. The one on the right is not periodic. The period then is how long it takes it to repeat itself. What would the period be on the one on the left? Yes. So pick a starting point. Doesn't matter where you pick because it all repeats. When does the graph fully repeat itself? Where would I stop at?
4.
At 4, yes? Even though it goes back to 0 here, it hasn't fully completed the cycle. Okay, for it to complete the cycle, it would be 4 units. The period of that function would be 4. Every 4 units, it does the same thing over and over again. Cool? Your trig functions do that. So what we're going to do first is make a parent function of all of yours. When you graph these, you're going to graph them like this every time. You're not going to use graph paper because it gets too like skewed. And so your graphs are going to look like this every time you do it. When you do a parent function, if you're thinking back to algebra 2, what we did for our parent functions is they were always the most basic version of our graph. Right? So the parent function of a cosine graph would just be the cosine of your angle. That would be my equation. When you did this in algebra 2, I always made you do the same thing at first every single time. What did we make every time we made a parent function?
A table.
We made a table to figure out what was happening. Right? When we plugged stuff in, we tried to plug in things that made sense, that gave us good answers, so we didn't have ugly fractions everywhere. Okay? If I want to get out pretty answers, so like ideally not a fraction and ideally not a radical, what would I have to plug in? What kind of angles give me pretty answers? Quadrantals, yes? That's how we get 0 and 1 and negative 1. So that's what we're going to plug in. So I want you, on here, we're just going to do our first rotation. So we're going to do 0, pi over 2, pi, 3 pi over 2. I'm going to run out of space. 2 pi degree is just 0 again? So we're going to plug those in. So you have to evaluate the cosine of 0. The cosine of pi over 2. Wake-ups. Not make-ups, it says wake.
I'm gonna fix it. You're not the first one. I think it says wake up. That is how many days you have left. No, 10. Oh.
Do you agree that cosine is x over r?
Yeah.
Okay, and I've listed out your ordered pairs, so you really want your x value of each of those ordered pairs over 1, because your radius is 1 for all of those. Cool. So, at 0, what's my x value? So it's 1 over 1, which is? At pi over 2, what's my x value? 0. So 0 over 1 is? 0. At pi, what's my x value? Negative 1. So negative 1 over 1 is? 3 pi over 2 then, what's my x value? 0. And again, what would it be at 2 pi? 1. Good. So I'm going to put and 2 pi there. It is 0, so I'm not going to put that. That means my tick marks, since those are my x values, are going to be my pi over whatever. Part of why you will not use actual graph paper, because it doesn't have pi on it. At 0, we are at 1. Pi over 2, we're at 0. Pi is at negative 1. 3 pi over 2 is at 0. And then 2 pi is up at 1. That is where it starts repeating again. That is one revolution of our function. So what we know is, in theory, at this next point, we go back to 0, because this is periodic. Do not put arrows on the ends of these, because that would tell me it's going to go that direction forever and ever and ever, and these will not do that.
You can get like a packet of the last section or just
Book. Sorry, dude. I'm going to label these other points. Negative 1, 1. Okay, but this is the parent function of my cosine graph. To prove to you that I'm not a liar, I'm going to pull it up. Come on, computer. There we go. Okay, here's my cosine graph. The portion that we graphed was this. We graphed this, but remember it is periodic. It goes forever to the left and forever to the right. So that is not the only portion you could graph, but it is the portion that we will graph because our first period is usually the most helpful. Okay, but it goes forever and ever and ever in both directions. The nice thing with Desmos, if you're using it to check yourself, it will give you those ordered pairs, and it knows that it's in terms of pi because it's smart. So it will even give you your ordered pairs as the pi value. So if you're using that to check yourself, that will be very handy. Cool? Cool. I'm pretty sure I just feel like I deleted it somehow. Somehow my page got deleted. We're going to do the same exact thing, but with sine. Not sure where it went. Now it's there. Same thing with sine. And I want you to start to do this. We're going to plug in the same values, because for sine, your important values are still the exact same ones. Yeah. I don't know why my hair find me those exact values of the same thing. Remember for sine, it's really y over r. So you can do the same thing and take your y values from all of those. So what's the y value at an angle of 0? 0. So 0 over 1 is? Cool. What's the y value for pi over 2? 1. So then it's 1 over 1, or just 1. What's the y value of pi? 0. And then the y value at 3 pi over 2? Cool. That is what your parent function should look like. And I'm going to pull it up on Desmos just to show you the pretty version. So the first period of sine is all of those points we just found. What you're going to find when we do these, I'm always going to make you graph 5 points, because 5 points gets you that full revolution, and that's when it starts repeating itself again. If I zoom out, you'll see that it goes forever and ever and ever. So in theory, I could be mean and make you graph it forever and ever and ever. I'm not going to do that. That's a little mean-hearted. Okay, so you're going to graph me 1 period. We agree that sine and cosine look real similar and kind of annoyingly so. Okay, keeping them straight is usually what gets, trickier. The way personally that I remember which one's which. Go away thing. No, it's not going to go away. You look at your first period of sine. There we go. Turn your head sideways. What letter does it make? Depends upon which sideways, but it's kind of a crappy S. Do we agree? Okay, the first period of sine should make an S shape. The first period of cosine, so remember the first period stops at 2 pi. What letter is that? That one's definitely a C, yes. The other one's like a backwards S. This one, you're just looking at the first period. Do you agree that looks like a C? Your first period of cosine should look like a C, assuming you don't shift it. Okay, so you will have to remember which one's which. So if that helps, that helps. But also remember how we got it, just by plugging everything in. Cool? Will this let me change it? Okay, what I have for you is a big old characteristic chart when it feels like going. And I will tell you that personally I memorized this characteristic chart just from looking at the graph that we just had. But this chart puts it in words for those of you who are fans of having it in words. So I'm going to talk through this. If you need to write this down or take a picture, go for it. But I'm just going to explain, because all of this you can get from the part we just said. Looking at the top, do you agree the period is 2 pi? When it starts repeating itself. Your domain is all real numbers, because that's everything that can possibly, it keeps going left and right and everything. Your range is your bottom to top, if you remember from algebra 1, or algebra 2, sorry, it goes from -1 to +1. Your symmetry will be the least important thing about this, but it talks about whether you can fold it in half. So like cosine you can fold in half. Symmetry about the origin means you would rotate it on sine. Your y-intercept for sine is 0. Again, you can get that from the graph. That's where our first point was. And for cosine is 1. There are no asymptotes on these. Your local max and min basically find your quadrantals. So for sine, your quadrantals are always coterminal, or your maximum, sorry, is always coterminal with pi over 2. With cosine, your coterminal is always, or your maximum is always coterminal with 0 or 2 pi. If you look back at your graph, Jocelyn, will you hit it back for me? The arrow. Yeah. On sine, where's the maximum? But like what y? X value, sorry. Pi over 2. So anything coterminal with pi over 2 will give me a maximum, and that's what that chart is saying. Where's my minimum?
3 pi over 2.
3 pi over 2. Everything coterminal with 3 pi over 2 will give me a minimum. Where are my intercepts? So all the whole number pi's, right? Same thing. That's where your x-intercepts will be at. We can go back one more. Same thing with cosine. Where are my maximums at?
0 and 2 pi.
And so all my maximums will be at those coterminals. Where's my minimum at?
Pi over 2.
Minimum?
I mean pi.
Pi. So everything coterminal with pi. And then same thing, your intercepts are at your pi over 2s. You will have to know that for doing, one more, this.
What?
Write it down and breathe. You go back to the chart. It is on Canvas if you need it.
Just trying to kill us.
I don't really think that is accurate in any way. I'm going to show you how to do this. It's going to be fine.
Just trying to kill our brains.
Nope. We're going to write one number next to each, plenty of space.
I hope it's the easiest thing I've ever done. Yeah. I'm not too bad about it.
Okay. What you are doing, all of the answers to these are quadrantals. So 32 pi is a quadrantal. It's just a lot of revolutions away. So far, I've made you subtract and find your coterminal, but you can also use the graph to help you do that. Okay? To do sine of 32 pi, we agree it's a whole number pi. Yeah, we're good there. 32 is not a fraction. 32 is also an even number, yes? In the event that becomes important. Going?
It has to be 0.
So, looking at this. At the whole number pi's, what is sine at? 0. Every single time, correct? And because it's periodic, it's going to keep always being at 0 at your whole number pi's. So, yes, I can't get this to work today. The answer to the sine of 32 pi is just 0 because you know it was coterminal with your whole number pi's. What does that mean negative 14 pi is? Also 0 because it is a whole number pi. So anytime you have a whole number times pi, your answer is 0 for sine. Okay? Bottom two are both pi over 2, correct? Something over 2? Yep. For your sine function, what are your over 2 values? Are they an x-intercept, a max, or a min, or could it be one of 2? If it's over 2, where was your graph at for sine? It was either at 1 or negative 1, yes? Okay, so we know that the value here is either 1 or negative 1. We do have to find the coterminal to be able to pick one. Okay, so how do we find the coterminal then? To figure out which one it's coterminal with? Subtract what?
4 pi.
Good. So we have to subtract in increments of 2 pi. So we have to find a coterminal here. How many 4 pi's? One more? So it's going to be minus 12 pi. So this is really the same as sine of pi over 2. Where was pi over 2 at on my graph? Positive 1. Good. So my answer is 1.
The top numbers are 4 by 3.
It won't all be. So someone asked me that last semester, and it ended up, I think it stops working on one of them, I show you. But there was one we did, and I was like, that's why you can't do that. And he said, yep, you're right. So if I find it, I'll tell you. Okay? Now, same thing happens on this one. Anytime you have sine, if it's over 2, you have to figure out which one it's coterminal with. So subtract off 4 pi on that one. many 4 pi's can you subtract from this?
6.
6, yes. So that means this is what? Good. Again, you can just look at your graph. That 3 pi over 2, your graph is at -1. It wouldn't then? Okay. I was like, I know I found one before that like it didn't, because someone had the same question.
If you subtracted it, you would get like 1 because 44 goes into that, but 45 would also be different by the
There you go. Yep. Okay, so you can use your graph to help you to find your exact values. I want you to do the same thing with cosine. These are the exact same angle measures. But look at your cosine graph and see what pattern you can figure out to know what the values of these will be. Or if you're a chart person, use the chart. Exactly.
What's the last one? Cosine.
Just now, these are cosine, yes. You're looking at the pattern that's happening on your cosine graph. At all your whole number pi's. What's happening on your graph? Is it a max? Is it a min? Is it a 0? It's either a max or a min, right? Okay, what you're looking at then, your maxes all occur at what kind of number? Even or odd? Even. So your maxes are always at an even number times pi. Your minimums are always at an odd number times pi. So that means looking at these immediately, since they're both even, what's the answer to both of those? 1. You don't have to find a coterminal, you don't have to do anything because that's an even number, and I know my pattern, those will both be 1. What if it was, just so you have it, -13 pi instead of -14? What would that be? -1. So if it's an odd number, same idea, and if you look at your graph at pi, it's at -1. That is an odd number. So there you're just looking at even versus odd. For anything over 2, where's your graph always at? 0. So these, you don't have to find your coterminal. These are the easy ones. Both are just immediately 0, and you can look at your graph and see that. So if there are no transformations to your graph, you can apply a lot of these patterns and use that. Questions on your parent function? Okay, because the first part of your test just makes you evaluate a lot of these values for me. The bulk of your test, though, we're going to graph things with transformations in them, which is technically the start of 6-4. There are 4 types of transformations that can happen to any graph. You can have a vertical shift or a horizontal shift, so move it up and down, and move it left and right. You can have a vertical stretch, so make it taller. And you can have a vertical or a horizontal stretch. All of these you talked about in Algebra 2. We didn't really do a horizontal stretch, but you're going to see it here. Reflection, yes, sorry, falls under that vertical vertical stretch because you flip it over. Yeah. So we will do all of those with these. We're only going to do 2 today because I'm nice. You're welcome. With this work. Okay? This equation is color-coded throughout the next 2 days of notes in the same way. So if color coding is your jam, these colors will show up on the next slide. This is your transformation form, like we talked about last year in Algebra 1. I've labeled everything here for you in different colors. This is the transformation formula we'll use both today and next time. Okay, and it tells you what everything does on there with some important equations that we'll talk about and apply as well. So I'll give you a minute to write that down, and then we'll talk about what all of that means. Phase will be your horizontal, and then the vertical will go down.
Period gonna like stretch it, right, then stretch it, or is period gonna like stretch it horizontally then?
Yes, it'll either make it wider or skinnier. Which two variables up there will stretch your graph either vertically or horizontally? So which one? Which variables, sorry, A, K, C, and H. What operation stretches? Is it multiplication or addition and subtraction? I heard both answers, so it's, you know. When you were back in Algebra 2, to stretch your graph or reflect your graph, was that multiplied by something or was it added or subtracted?
Multiply.
Multiplied. So the two things in there that are multiplication with your problem are what will stretch your graph either vertically or horizontally. So the A stretches it vertically, because anything outside your parentheses happens to your Y value. So it stretches it vertically. Here it's called our amplitude. It's how tall your graph will be. Your amplitude, as it says, is the distance from your max to your min, max and your min to your midline, which is just the middle of your graph that's going to oscillate around. The K stretches horizontally, so it's going to change our values that we plug in and stretch it, changing your period, making your period either happen quicker or more slowly. Okay, your C and your H then are your shifts. Inside the parentheses means it happens to your X, so that's going to go left and right. So the C shifts you left or right. The H shifts you up or down. So a lot of this does go back to your Algebra 2 days of graphing. when we do this, we're gonna use a lot of the information to kind of figure out what's really happening, and then we're just gonna apply our pattern. So we're gonna use, as it says at the bottom, the positive or negative, figure out whether it was reflected or not, and we're gonna use the sine or cosine like we talked about a minute ago to figure out our shape. So figure out whether we started our max or whether we started our zero like we talked about on our parent function. So we're gonna use those quite a bit, which is why I'm pretty sure the next slide, maybe. Yep, so what I'm gonna do is remind you what all 4 of those shapes should be. You have this already in your notes, but I'm gonna sketch these for you. Where did your sine parent function start at? 0, max, or min? I've heard 2 answers. You're 0. So if you look back, it started at 0. Then it did what?
Went on to 1.
Good. And then it went.
0. 1. 0.
Okay. So if we have a positive sine function, it's going to look like this every time. That's what we're going to sketch. Your job is going to be to label the max, the min, and all these points, and that's what I'm going to teach you how to do. But your sketching should look like this. If it is a negative sign, what's the only thing that's going to change? Good. So you start still at 0, but now I'm going to go where? Good. You'll go down. It is reflected, just like it was reflected back in Algebra 2. So again, you will figure out how to find the max, the min, and all those little tick marks for the points based on your shifts. But it will still look like that. Where will cosine start? Mm-hmm. And what will be the only difference between cosine and negative cosine? It's reflected. So it'll be start at -1 and then move like this. Okay? The bulk of your points will not come from your shape. That will be points. The bulk of your points will come from your ability to label all of those lines, which is what we're going to spend most of the time talking about. Those shapes just come from your parent function. But every single graph should look like one of those. Cool. What's on the next page is some steps. These steps have all the steps, assuming I did all the transformations. Today we're only going to do 2 transformations, but next time we will do all 5. So if you want to write down all 5 steps today so you have them for next time, that's perfect. I will circle which ones we are going to do today. This is again color-coded just like the equation was before.
Did we get these next day?
Yes, I have them on both days' notes. So the only ones we will do today is 2, 3, and 4. I'm not going to give you an H value or a C value today. I don't do either shift, I'm just going to do both stretches. So I will stretch it, so that's where today we will only do 2 through 4. You will eventually do all of them, so if it helps you to write everything down now, then that's perfect. gonna put in an amplitude changer or a period changer, so it's only gonna be that A and that C value. This is gonna change my parent number. So we are gonna have different like numbers on our axes than we had before. That 3 is going to do what to it? Make it taller. It is a vertical stretch, yes? Okay, what's the 2 gonna do? It'll change it horizontally, yes? Because inside it always does the opposite. Yes. So the 2 is gonna shrink it in, and 3 is gonna make it taller. What will the negative do? Flip it. So I'm gonna have a lot happening. Every number is gonna change from what it was before. We're gonna talk about how you do that. Today you're not gonna have to find a new midline because I'm not gonna change it. What is my midline if I don't move it? What was the middle of my graph? 0. So y equals 0 is gonna be there. You will have to label that. Because again, the labels, the numbers that you put here is how you get your points pretty much. To find your max and your min, you have to know your amplitude. What's my amplitude? 3. This 3 is your A value, and it tells you how far, I should have, you know it's a 3. That is your A. Tells you how far above and below your midline your graph goes. So how far, what will the max value now be? Max value? Positive 3. What will the minimum be? Negative 3. So you have to find me both those points. Good to there. Okay, now we have to find our new period. Because our graph will not take a full 2 pi to go through one revolution because that 2 is there. So you're going to use this formula every time. And you're going to do that your period is equal to 2 pi over k. What's my k value? 2. So I'm going to plug that in. So how long will it take for my graph to start repeating itself? Just 1 pi.
Is the bottom always going to be like a 2 pi and then
So this formula will always stay the same. And you'll plug in whatever your k value is. So this was my k.
I mean, like the line of the thing is always going to be like 2 pi. The bottom. Or pi over 2 and then pi.
These?
Yeah.
No, this is what's going to change right now.
Oh.
So it will not be that because it's not taking 2 pi to get there, it's taking pi. Whatever this number is, goes to your last tick mark. Because that's how long it takes to do your full revolution. Before our last tick mark was 2 pi, now it's pi. Everything will shift in proportionally, so you have to know how to split that up. How did we split that up before?
Minus it by 3.
I know it's pi over 4, but I don't know how I'm supposed to do it.
Because each tick mark represents what portion of this? A fourth. So this is 1/4 of the way. You're going to do a fourth times pi, so this is pi over 4. Which means this is how far? Because it's halfway, yes? So this is pi over 2. This is how far? 3/4 of the way times pi, so this is same pi over 4. You will always use these same fractions. You'll do a fourth times your period, a half times your period, and 3/4 times your period, and that will give you your tick marks. Because you're a fourth of the way, half of the way, 3/4 of the way. Yes, sir.
So can't you just take your tick marks divided by your k? Because pi over 2 divided by 2 equals pi over 4. Pi divided by 2 equals pi
So
over
then your tick marks divided by k.
2. Yes.
Let me think about if that'll always work.
Okay.
Because it should, but I don't want to tell you it will and then it doesn't.
Alright.
Okay, so I'll think about it. Okay, everyone know how we got those points? Now you have to sketch it. Since this is a negative sine graph, first off, you know why it's a negative sine graph? It's a negative and this is a sine. Where does your negative sine graph start at? 0. Then where does it go? To your minimum. Then where? Then to your And then back to 0. Done. Questions there? Make sense? You're gonna get really good at it. Write this one down. It sounds real creepy. Theta. Yes, that should always work. You're really just doing 2 pi divided by k anyways to get your whole number, and then it will be incremental. Multiply. Yes, it should be. I'm gonna double check it, but like doing the math in my head, it should work out. Which will be 6, and so then you have to multiply. And since it's yes. I'm gonna double check it while we do it, but it should work every time, so yeah. What's your midline? 0. We did not move it up or down today. I'm not going to move it up or down. What's your H value? Whatever's added outside of your parentheses tells you if it was shifted up or down. Or subtracted, yes. Today I'm not going to move it vertically or horizontally. We're just going to stretch it and straighten it. What is your amplitude though? 2/3. So my maximum is not 1, it's what? 2/3. And my minimum is not -1, it's -2/3. Again, you get all your points from labeling the axes, so make sure that you're labeling those. Not all, but most. What's my K value? Good, it is 1/3, since it's over that, so to get my period, it is 2 pi over 1/3. Yes? How do you simplify that complex fraction? And so whatever that is your last mark. And then go through and do 1/4 of 6 pi, and 1/2 of 6 pi, and 3/4. I don't know why I did that, of 6 pi, to get your tick marks. So again, you find your full one, and then you cut it into 4 even parts, because your graph will be kind of symmetric throughout, not symmetric, but evenly distributed. What's 1/4 of 6 pi? What's 1/2 of 6 pi? 3 pi. What's 3/4 of 6 pi?
9 pi.
Most of your points, like when I grade these questions on your test, they're usually worth like 5 points. 4 of your points you get if you just do this. The one other point comes from can you sketch the correct graph. So make sure that where these numbers all came from makes sense. And then throw your water on the ground. Any questions on those numbers? And your chapstick. Where will this graph start at? Then it will go to your midline, down to your minimums, back to midline, back to maximum. Rude. Oh, no. Don't put arrows because that tells me it goes down forever and it doesn't. But do extend it. I have little wings on mine. Questions? another graph. How do you feel about graphs? Like if I show you one. Like we fine with that?
Yep.
Yep.
Know how to do it.
Like that one's fine?
Dude, I'm telling you, you can't throw anything in there.
I believe that. You're right. You can do all this stuff. So we want to write equations then?
No.
Do we have to learn how to do that?
Yeah. Today it's real straightforward.
No.
Again, these 5 steps work if I give you everything. I'm not going to give you everything today. Just like before, we're only going to do like 2, 3, and 5 this time. Because I want to give you a phase shift or a vertical shift. But you're going to write equations for everything too. Writing equations? Today's are the easier ones. Because once you find A and K, you're done. Basically. Reverse. Yes, the top one, sorry, yes. It's doing the average of it. The laziness is real. You have time to write. I got that. Yeah.
Honestly.
Just like summarize it. Anyway.
There's no summarizing that. It's all in
Midline, amplitude, K, C, done.
one. Well, I mean, I wrote what each one means, so.
Questions on what any of these are. It's kind of the same formulas that's on the regular page. Like you're still using period equals 2 pi over K. You're still using phase shift equals negative C over K. For the midline, you're doing the average of your max and min to find the center. Amplitude, I'm usually just going to tell you. So there's that. But if you need to find it, and you know your max and your min, you just use that information to find it. Can I change it? Do we need another minute? Still going? In a minute. That's why I was just remembering that I do have. Yes, sir.
So that's not like H times max plus min over 2, that's just like.
That's just find H and then a formula.
Okay.
Correct. Yes, it is not times.
So
Each of them, like, you could just put an equals next to that for each parentheses. Because it's phase shift equals this, period equals that. Your equations are going to look like this. Or your questions are going to look like this. It's going to tell you what equation to write. And then it's going to give you some information, and you're going to have to apply it. I cannot give you a paper about it. I don't remember what it is. plugging into that formula, yes? I've already told you that today I'm not gonna give you a C or an H, so you don't care about that. You just need to find your A and your K. Do I know either of them right off the bat?
3.
Yeah, what's the 3?
The A.
The A. So A is 3, because they told me. Here I'm gonna tell you, we're gonna do word problems eventually, where I won't tell you.
Wouldn't you put minus 3?
Yes, good. It is plus or minus, because I didn't give you any idea if it was reflected or not, so it is important you keep that plus or minus there.
But wouldn't it be 2
Amplitude, it would be 3 either way, because it's just the distance from your 0 to your max, or your 0 to your min, which would still just be 3. To find your K value, you need your period formula. So I know the period is 2 pi over K, and if I plug this in, I know the period. So 2 pi over 3 equals 2 pi over K. Some of them are going to be real simple, like K is 3. Do we agree?
So like, can you just pull it out of the denominator?
If it looks that pretty, yes. Your numerator won't always be 2. So like that's where you might have an issue. Done. Hello? Yeah. Okay. Questions on that one? Write this one down. Because if it's, you can cross multiply basically. Yeah, and they'll end up canceling. That's what that. So like on this one, since your numerator is not 2 pi, you can't just pull that directly. We're going to plug this into the same equation. What do I know right off the bat? Good. So it's already plus or minus 2 cosine of something theta. Yes?
How do we know
And on your test it will say, write a cosine graph. Cool. Then we have to use our period equals 2 pi over k formula to find our k value. This one is not as like obvious about what it is. How do I solve a problem like that? Put that 3 pi over 1 and just cross multiply it. You're going to have 3 pi times k equals 2 pi. Good. Divide by that 3 pi. Yes, sir.
So if I know that that's 2 pi multiplied by 1/2 or 3 halves, can I just like put that there? Because now it has to be divided by,
So then it would be divided by that number, and so you put 2/3.
yes.
Yes. Done. Again, today you're only going to have your stretches, so nothing else will be there.
Yeah.
It's summable. Your homework's on the board. Your homework, remember, I shortened part of it, and then I combined them. So on the graphs and stuff, what I put up there is do even or odds or whatever makes you happy, because as long as you're practicing, that's what's going to help you get better. I do not, if you're going to do half of them, which is what I'm basically telling you to do not just do the first half, because the first half won't get you like the harder examples. You feel me? Try like all the evens or all the odds or whatever you want. My answer key will have some of everything, and then per usual, if you are not doing them correctly,